Okay, we've got a circle here of radius 5. There's a point on the circle at x is 4 and y is 3, and a tangent to that point. We have to find the equation of that straight line, that tangent. Okay, so we need the equation for a straight line. Well, that is y equals mx plus c. But there's a second way of writing this equation which is better, and that's this. Y minus y1 is m times x minus x1, where x1, y1 is any point on the line. Any point on the line. They're the same equation, they're just two different forms of the same equation. The second one is better because you can use any point on the line. Doesn't matter where it is. And that's the obvious choice for this question because we have a point on the line. We instantly know x1 and y1. x1 is 4, y1 is 3. We have the point on the line. So we've got x1, we've got y1, we just need m, which incidentally, m is the gradient. Okay, m is the gradient. Right, so we just need the gradient of this line and we've won. How do we get that? Well, there should be some numbers ringing a bell here. 4, 3 and 5. That's familiar, isn't it? Let's draw a right angled triangle on here. Now we know that that's 5. This is a circle of radius 5. If it goes through -5, -5, 5 and 5 here, the radius is 5 at all points. And we know this distance here because that is x equals 4 and that's 0, so that distance is 4. Same here, that's y equals 3, so that distance is 3. Sorry, that distance is 4 actually. That distance is 3. Ignore that. It's a 3, 4, 5 triangle, Pythagoras. So, why have I drawn that? Well, that line, because that's a tangent, the tangent is at a right angle to the radius of a circle. Okay? So, that means if we know the gradient of this line, we can immediately work out the gradient of that line. When two lines are at right angles, the gradient of one is the negative inverse of the gradient of the other. Okay? So, what's the gradient of this line? Let's call that m1. Gradient of this line, m1, is the rise over the run, which is, the rise is easy, it goes up 3, and the run is easy, it goes along 4. That's it. Gradient of that is 3/4. So now we can work out m, the gradient of the line we actually want. And because these two are at right angles, m1 is -1 over m. Okay? Just to go over it again, if two lines are at right angles to each other, the gradient of one is the negative inverse of the gradient of the other. And you can rearrange this, it works both ways round. Therefore m is -1 over m1. Okay? Works both ways round. So, therefore, the gradient we want, m, is -1 over m1, is -1 over m1. m1 is 3/4. Okay, therefore gradient we want is minus 4/3. Dividing and then dividing again by 4, so the 4 flips up to the top. That's one way of thinking about it. Or you can just write down straight away 3/4 flipped over a negative. So you can go straight to there if you want. Anyway, we've got m. We've got everything. Everything to put into this formula for a straight line. So let's do it. We have y minus y1, there's our point, that's x1, y1. So y1 is 3. Y minus 3 is the gradient, minus 4/3, times x minus x1 is 4. x1, y1 is any point on the line. We've been handed 4,3, the point 4,3. Okay, multiply out the bracket. Y minus 3 equals minus 4/3 x. Minus 4 times minus 4 is plus 16 over 3. Okay, bring the 3 over there, add 3 to both sides, so we get y equals minus 4/3 x plus 16 over 3 plus 3. Therefore, y equals minus 4/3 x plus 16 over 3. 3 is the same as 9 over 3. Basic fractional addition, make the denominator the same. Therefore, y equals minus 4/3 x. 16 plus 9 is 25 over 3. There you go. That's it. So, the formula of this straight line, or the equation of the line, is y equals minus 4/3 x plus 25 over 3. And you can see it's in this form here. Okay? Like I said at the beginning, I prefer to work with this form of the equation of a straight line to answer questions to begin with, because you can use any point on the line, x1, y1. You're not restricted to c. C is the y-intercept, wherever the line cuts the y-axis. But for your final answer, you have to present it in this form, and that's what I've done here. Y equals mx plus c. So the y-intercept c, you're not asked this, but just for your information, c is 25 over 3. So it cuts up here somewhere off the screen. It cuts the y-axis at the value 25 over 3. And the gradient is minus 4/3.